We'll proceed in vector summation and integral calculus. Okay, vector summation and integral calculus. This is a discussion that we have started. What is vector summation and integral calculus? This actually it has extremely usefulness in the artificial intelligence where we will have statistics. So we will take course of the statistics only. I don't think it is extremely useful in in the differential equation and whatsoever. In case study where the items are large numbers, if items are large numbers, if items are large in number, then breaking the full item into n different parts and solving it part by part and then summing it. While solving it part by part, we need a vector. Introduction of vector in solving part by part. This is what we are looking in this discussion. Little bit I'll go in the basics of integral calculus before I proceed. What is basic of integral calculus? Consider this is a rectangle. This is a rectangle. If this is a rectangle, then this is width and this is height. This is height and this is width. This is a rectangle. If it is a rectangle, what is area of this rectangle? Consider this is x-axis and this is y-axis. This is y-axis and this is x-axis. Here it is origin. What is area of this rectangle? Then if I say this is x-axis, this is y-axis, then y into x, that is the area of rectangle. Or I can say fx, function over x. If this is x-axis, then this is function over x-axis. Function over x-axis into x is the area. Okay, but it works because this is the flat line. It works because this is a flat line. If this is a flat line, then height into width will give the area. What about if this is not a flat line like this? This is a circle, or like this, where fx equal to x square, like this. This is not a flat line. Okay, this is x-axis and this is function over x, that is x square. Consider this is x square. Then what is the area underneath it? What is the area underneath it? We saw if it is a rectangle, the area underneath is height by base. What about if it is not a rectangle? What is area underneath it? What about if this is a circle? Consider x-axis is here and y-axis is here. Consider x-axis is here and y-axis is like this. X-axis is here, y-axis is like this. Hop, 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 hop. What is the area of the first quadrant? Okay, what is the equation of the circle? Y equal to square root of a square minus x square, and this is the height. Equation of any line means height. Okay, it's nothing more than that. What is the height? Height is variable with the x. That's why it is called function over x. This is the height. When this is origin, when x is a, height is 0. When x is 0, height is maximum a. Okay, in between it is the height. Height into width is the area. Fx into x is the area. If I say that consider fx into x is the area, x is minus a to a, this is origin, then this is the full area, top half area we are talking about. Integration x1 to x2, function over x dx is the area underneath. Function over x means height. Dx means d is to give a sign that it is integral calculus. It is not normal multiplication. Function fx is the height into x, x means width. Fx is the height into x means width. Integral calculus is nothing but a pure multiplication only. height multiplied by x. That is the area. But fx is varying with the x. So height is not constant every moment. In that fashion, we go with the integral calculus. Fx, then instead of x, I write dx. What is fx dx? From x equal to minus a to a. What is fx dx? Okay, I can chop this x-axis into n different parts. Chop this x-axis into n different parts. Now for each part, what is the area? Fx into whatever the width of this part. There are n number of sections I am getting on x-axis. If I chop x-axis into n parts, consider the ith section. The width of the ith section is delta xi or 2a by n, delta xi. At this moment, what is fx? Fx is fx at x equal to whatever it is the value it has in the ith section. I'm talking about the ith section. Function over x where x belongs to ith section into delta xi. Delta xi the width of that section. This is the height, this is the area. If I add all the area, it is fx dx. It is nothing but summation. Means integral calculus is also summation of a sectional area, not only the height. Subsection area. This is the subsection area, this is the subsection area. These are the subsection area. There are n areas. Summation sigma sign I equal to 1 to n, area of the ith section. What is area of the ith section? That is a function over x at x equal to I into delta xi. Function over x into delta xi. This is area of the ith section. If this is the area of the ith section, if I add all the area, it becomes fx dx. This summation I equal to 1 to n. Summation I equal to 1 to n. And then fx x at the ith section delta xi. If someone does the summation, then it is equivalent to summation I equal to 1 to n. Summation I equal to 1 to n. Summation I equal to 1 to n, and then area of the ith section. If all the area I add, it becomes fx dx. Summation I equal to 1 to n. Fx at x equal to x for the ith section into delta xi. Fx dx. Summation I equal to 1 to n. Summation I equal to 1 to n. Function over x at x equal to ith section into delta xi. Delta xi is the width. Okay, means one subsection area is function over x into delta xi. If I generalize, if I sum it for all sections, I get fx dx. Is it the real calculus? That actually the integral calculus, it goes minutely, like you see some lady is sewing a cloth. Means very minutely, thread by thread it is sewing. It is integration is nothing but calculation of the area by every moment sewing the height into the width plus next height into the width plus next height into the width plus next height into the width. If I divide it into n sections, where n tends to infinity, means each section is infinitesimally small. In that fashion, the top part will behave like a straight line. Means it will be a rectangular region, but next rectangle will be higher. The next rectangle will be higher. The next rectangle will be lower. In that fashion, but it will be accurate because n tends to. Is it the way integral calculus works? Certainly not. This is not the way integral calculus works. But means fx dx integration from x1 to x2 is same as dividing x-axis from x1 to x2 into n different parts, and then sigma summation I equal to 1 to n, where n is the number of sections I divide between x1 to x2. Function over x belongs to ith section. Delta xi, where delta xi is the width of the ith section. That is the area of one strip. If I add for all the area, it becomes fx dx from x1 to x2. x1 to x2, I chopped into n different parts. Both are same. Is it the way actually? It is intricately, very intricate manner. Someone is sewing the height into width plus next height into width plus next height into width. If someone sew all the sub area, it becomes integral. Is it the way this much minutely integral calculus calculate the concept? If someone I believe Sir Newton was the person who was behind the calculus. He invented calculus. Did he think that this will happen? Like, certainly not. Integral calculus has nothing to do with something sewing something so intricately. It happens by default by side part, okay, by side business. By side business it happens, but it does not do in that fashion. Integral calculus works purely in the then how someone calculate if my function is sin x. What our video, I believe somewhere we have talked about it, how to calculate integration of the sin x. Sin x means if I have a sin x function, if I have a sin x function like this, then if I say integration of sin x, if this is the sin x function and this is x-axis from 0 to pi, this is 0 and this is pi. At pi by 2 it is maximum. What is area of sin x between 0 to pi? Sin x dx, x is 0 to pi. That is the area of the sin x. How someone calculated the integral of sin x? Did he go and cut the between 0 to pi n different part where n tends to infinity, and each part he calculated the area and he said the integration of sin x is minus cos x? Certainly not. I believe we have talked once that how to calculate, how integration calculus came into the picture, because people started seeing anomaly while calculating the multiplication. If someone is calculating the multiplication, normal multiplication with area of rectangle, both are same. Normal multiplication is area of rectangle only. If this is what is the area of this rectangle? This is nothing but height by width, simple multiplication. Okay, but what is the area of this line? This is x-axis. What is area underneath this line? I cannot say height by width. It will not work. There people started thinking that if I have algebra, multiplication is very good as far as numerical science is concerned. But in numerical science, if I say I have 2 into 3, 2 into 3, then what is the multiplication? 2 into 3 is 6. What is 2 into x? 2x. What is x into x? I don't know. X square. No, no, no. The first x is varying with the next x. This is x-axis and another x is varying with the x. What do you mean? Okay, what I mean is that a person is running. A person is running in the ground. At the end of 1 minute, okay, he is running in the ground at a speed of 10 meter per minute. 10 meter per minute. Now tell me how much distance he has traveled at the end of 5 minutes. 10 into 5, 50 meter distance he has traveled. 10 meter per minute is his speed. After 5 minutes, he has traveled 10 into 5 equal to 50 meter. Okay, then someone will say, okay, how much distance he had traveled at the end of 10 minutes? How much distance he had traveled at the end of 15 minutes? What is 10, 15, 3? Say how much distance he had traveled at the end of x minute. Okay, yeah, that's what. 10 into x. Okay, keep changing x. 10 into x is the distance he has traveled. If 10 meter per minute is his speed, right? Yes. Then at the end of 1 minute, 2 minute, 3 minute, 50 minutes, many things you are asking. Just write it. 10 into x is the distance he has traveled. Keep changing x, you will get the how much distance he has traveled. Next person is saying 10 is not speed actually. His speed is x. What do you mean? When minute is 0, then his speed is 0. When minute count is 1, then his speed is 1 meter per minute. When minute count is 10, then his speed is 10 meter per minute. What do you mean? This is how it is. He is increasing his speed. Now tell me, at the end of x minute, what distance he has traveled? What is his speed? X. X means when where X is minute. At moment when minute is X, his speed is also X. X meter per minute. Now tell me how much distance he has traveled after X minute. X into X, X square. 10 into X was the distance he had traveled. Instead of 10, now it is X. X into X, X square. Certainly. Then people started thinking that something different is going on. Then people remember that if I need to multiply 10 into X, then I can multiply through the rectangle. I believe tens of times I have repeated this. Means I have a rectangle like this, and this is x, that is time, and this vertical is the velocity, that is 10. At any moment, if I calculate the distance here travel, that is the vertical multiplied by the distance. Okay, means I can calculate multiplication 10 into x with the seeing the curve, seeing and graph also. If I draw a graph where x-axis is the time and the speed is the vertical, then vertical into x-axis is the area he has traveled. The area, that is the area he has traveled. Then people started looking the solution with the area. Area is another way to calculate the multiplication. Repeated addition is multiplication. True. 10 into x is same as 10 plus 10 plus 10 plus 10 plus 10 plus x time. That is also 10 into x. 10 into x is also, if I have x-axis and I take vertical as 10 and draw a rectangle and get the area of the rectangle, that is also 10 into x. Then what is x into x? If this is x, then this is x. Function over x is x. From 0 to x, how much he had traveled? That is the area as per the concept. This area is nothing but the area of a rectangle by 2. If this is x, this is x, area is x, area of rectangle that is formed like this full is x square by 2. So now instead of saying fx into x is the result, they said fx into dx. D means integral calculus. Integral calculus means calculating multiplication by drawing the graph. That's it. What is integral calculus? Integral calculus means multiplication of the algebra. Why drawing a graph and calculating the area? If you use this methodology to calculate the multiplication, this methodology is named as integral calculus by Sir Newton. Why he did like this? This is up to him. This is what he thought. Okay, and this is the way Sir Newton had thought. So now it is from where to where? 0 to x. From x1 to x2, how much distance he had traveled? Fx dx from x1 to x2. This is the way he said. Okay, why transistor? Why transistor sign is like this? Base, emitter, and collector. This is what I forgot the name of the person. Okay, he is also a sir, means he did a very big thing. He received a Nobel Award also in 1953 or something like that. Okay, I keep forgetting his name. Who invented transistor? Means I mean the semiconductor, silicon transistor, semiconductor, not the triode or something like that. Okay, so it is up to him. But transistor is nothing but dual diode only. I mean a diode with two junctions. That's it. It's not dual diode. You add two diode and it will become transistor. It's a simple diode with two junctions. Someone can mark it as a straight line also with 3 points. That's it. But one base and then collector and emitter. I personally don't like this sign because it confuses people. It confuses people that okay, some base is this side and then collector is. Actually, it should be a straight line. Three dots should be there. Three dots should be there, or two dots should be there. I'm sorry, two dots should be there, or one box should be there, and then two dots or two lines. The way diode is, and three section will be created. This way, someone would understand it's a simple diode with two junctions. Okay, where the if it is NPN, then first and end are doped in a negative fashion, and between is with positive fashion. I mean, germanium is the positive, create the holes, whereas silicon with the another one, it created the non-hole electron or something like that, negative ion. Okay, this way it is simple to crack it, but this is how I still again forget the name of the person in United States. I believe he was a professor or something in college, university. He invented the semiconductor, but this is how he thought. And since then, it is working like that only. And field effect transistor that is also more or less analogous to that symbol one. This is how Sir Newton thought about it. Integration snake sign from lower limit to higher limit, function over x, that is all right. Instead of into x instead of dx. Now people learned that the integration of x is x square by 2. Whatever integration of x square, then through some media people learned it is x to the power 3 by 3. What is to the x to the power 3? It is x to the power 4 by 4. People understood. Integration of x to the power n is x to the power n plus 1 by n. Now, at least for polynomial, people came to know. Then slowly they started applying their mind to the trigonometry, logarithm, everything, step by step, using the lower level at the higher. If someone is calculating for trigonometry, then polynomial integration is anyway available to him. So if you bring the sin x expression into polynomial some way, then result is with him only. Okay, this fashion, the complex integration started arising. It is purely calculation of multiplication through the graphical way. That's it, through the area. But later people started talking about anti-integration. Anti-integration, if one is area, then anti-integration would be the anti-multiplication. What is anti-multiplication? Okay, 1 by m. What is anti-multiplication? I'm sorry, it is not 1 by m. Anti-multiplication. If 2 into 2 is multiplication, then what is 2 by 2? Then it is division. Okay, anti of multiplication is division. I think it is correct. I said, okay, 1 into x is multiplication. 1 by x is the division. Anti. Okay, then anti of the integral calculus, they called it differential calculus. If integral calculus is analogous to multiplication, then differential calculus is analogous to simple division. Simple division. Okay, what is normal division? Normal division happens for the numerical signs only. What is 10 by 2? 10 by 2 is 5. If I have two bags, one had 10 tamarind and one had 2 oranges, how many tamarind per orange? 10 by 2, 5. Per orange there is a 5 tamarind. If it is numerical sign, then division will work. Okay, how many tamarind per orange? Someone saying, then the answer is 5. Okay, but miss, this is the, if I talk about the tamarind and orange relationship, then it is, this is the orange. Okay, if this is the orange, I think so. Okay, if this is the orange, then tamarind is 5. Hope, I believe tamarind will be like this. If this is one orange, then tamarind is 5. If two orange, the tamarind count is 10. I think so. Okay. Means it is a straight line whose slope is 5. If orange is 10, the tamarind is 50, 5 times. This is a straight line. If it is a straight line, then what is the division? Means vertical by horizontal. If it is not a straight line, then what is vertical by horizontal? It is not constant. Everywhere it is different. Like we have given example like this. Okay, what is the vertical by horizontal? Everywhere it is different. This is y equal to x square. X square is the equation. When x is 10, then y by x is 10. X square by 10, 10. When x is 2, then y by x is 2, 4 by 2. It is different everywhere. Then how I can say what is division? Every moment division is different. Tell me momentarily division. When x equal to 5, then height is 25. At this moment, what is the division? What do you mean? Okay, you said everywhere division is different, right? Yeah. At a particular moment, what is the difference? What do you mean by at a particular moment? What is your division? Division means a straight line. Yeah, this is what I'm talking. Okay, if it is a straight line, then division will work. No problem. Every moment, if you take y by x, y by x, y by x, it will be same. So I can just divide it and say this is the division. But if I take the curved line, then division is not same. Everywhere it is different. Then at any moment x equal to x1, tell me what is the division. What do you mean? At any moment x equal to x1, if you hit here, then at that moment, at that particular moment, if you see through the telescope or binocular or magnifying glass, it will appear as a straight line. Are you talking about a tangent line at that moment? Yeah. Tangent lines means the line direction at that moment. Everywhere line direction is changing. At that moment, what is the line direction? Means you're talking about that moment. What is the tangent or a straight line? Yeah. When it comes to a straight line, you can tell the division. Okay, what is the division at that moment? If I take any moment, then I'll take a small strip here that will behave like a straight line. Then if this is delta x and this is delta y by delta x, this is differentiation. If line is not a straight line, it is a curved line, then what is the rate of change? At a particular moment. If when a moment comes into the picture, each moment the division is different, then we denote it as dy by dx rather than y by x. Y by x is constant, then y by x will work. Dy by dx is not required. If fx into x, fx into x, where fx is constant, then fx dx is not required. These are non-linear equations when it comes then. So differentiation is division at a different moment. Different moment division will be different because the line is passing. That line equation is different. Division is for a straight line. I'm doing for a straight line only. At different moment, different. Okay, if you club together, it will differentiation is still it will become an algebra. You keep changing x, you will get different divisions at that moment. These are the calculus anyway. Okay, so we will proceed now in calculating the area of a circle. Okay, this basic concept is extremely important. Extremely important. What is basic concept of a vector? If there is an energy source going toward x-axis, now at a moment it is at origin, and there is another energy source that is going toward y-axis. They meet at a point. Consider it is 2I and is it 3J. Means there is energy going in J direction and its strength is 2, 3. And one energy is going in I direction. This is origin, its strength is 2. If they meet here, then they become 1 and they move like this. What is this new energy? Is 2I plus 3J. This is the vector. That's it. The new energy, what will be the magnitude of new energy? If there is a 2 energy and 3 energy is there and they combine together, they form another energy, then it is 2I plus 3J. What is the power of another energy? 2 square plus 3 square square root. It is not 2 plus 3 somehow. Because this is wrong. Someone would say this is wrong. The way you are saying this is wrong. If energy with 2 power 2 going in I direction, if energy of power 3 going in J direction, and they combine together and they go like this, the net energy is 2 plus 3. Okay, what you are saying? It is 2I plus 3J. I understand that direction will be like that. I understand. But the power of the energy will be 2 plus 3, not you are saying 2 square plus, what is 2 square plus 3 square square root? That is 9 plus 4, 13. 13 square root will be less than 4 also. But it should be 5. Certainly not. Now consider that one energy is going like this 2I. One energy is going like this minus 2I. It is in reverse direction. They meet at the origin. What is the net energy? 2I plus minus 2I, 0. It should have been 2 plus 2, right? Okay. Means energy is moving in y direction. When they combine together, net energy matters in that fashion. If they are hitting at orthogonally, there is a loss of energy. If they are hitting each other at exactly opposite direction, there is a totally loss of energy. If it is 2I and it is minus I, the net resultant will go in this direction. But it will be only I, 2 minus 1 I. Only I will be there. If they are going in 90 degrees, they will hit together, there will be loss of energy. And they will move like this, whose strength will be a square root of 30. 30. Okay, that is the concept of vector. Xi plus yj, it is combination of two energy. One is of strength x, which is variable with x. One strength is y, that is variable with the y combination. Someone can understand. Anyway, the concept is usage of vector calculus in calculating something, then dividing into n parts and calculating it. We are in phase of calculating the area of something where this is Cartesian coordinate system. Consider this is x-axis and this is y-axis. This is Cartesian coordinate system. I have a circle whose whose function is x square plus y square equal to a square, or y equal to plus minus square root of a square minus x square. This is the equation. Fx equal to plus minus a square root of a square minus x square, function over x. Calculate the area of this curve. Calculate the area of this curve with whole area, or area of this curve with the x-axis. Multiply it by 2. You'll get the full area. Now we saw that to calculating it, we took a kind of a privilege to have another coordinate system. This is xy coordinate system. I have another coordinate system called polar coordinate system. This is a technology that is used to achieve complex computation. If I have a problem in xy, it is pure simple problem. X-axis, y-axis, there is a circle, and calculate the area of the circle. I don't know. What is the function of this curve? Function of this curve is function over x. What it is? Plus minus square root of a square minus x square. How to calculate area? I don't know. It is very difficult. Oh, I know. Fx dx. Fx dx. Limit minus a to a, where minus a is the, if this is x-axis and this is origin, minus a to a is the radius. Limit minus a to a fx dx, it will give the area underneath it, multiply by 2, it will, I know. Okay, what it is? Then it is the square root of a square minus x square dx. Okay, this is the one concept people know. How to calculate by dividing it to n different parts. This is the another way we are talking. To have this, we will have another coordinate system. This is xy coordinate system or Cartesian. There is another coordinate system called r theta coordinate system. This is theta. This is r. This is called polar coordinate system. And this is xy plane. This is x-axis. This is y-axis. This is Cartesian coordinate system. My circle is lying in Cartesian coordinate system. Whereas what is relationship between this Cartesian coordinate system x and y and polar coordinate system theta and r? Relationship is x equal to r cos theta, y equal to r sin theta. That is the relation. What do you mean? What I mean is that if I map this circle in xy coordinate system into theta r plane, then it will be a rectangle. This is what I am trying to say. This will be exactly as a rectangle. This will form a rectangle here. If there is a circle centered at the origin, then if I say, what you say? If I have theta r, what is theta r? X equal to r cos theta, y equal to r sin theta. Theta equal to tan inverse y by x. If I take points along the perimeter, then I have set of x and y. For every x and y, if I calculate theta variable, that will be tan inverse y by x. Whatever comes in radian, that is the theta. Okay, whatever comes, what is r? R is x square plus y square. If x equal to r cos theta, y equal to r sin theta, x square plus y square equal to r square. If I have set of x square, y square at any point x comma y, what is the theta as per the calculation, and what is the r? If I keep changing x and y and try to draw in theta r plane, it will draw a rectangle. Okay, with variation of theta, there is no variation in r is seen. R square equal to x square plus y square. Okay, mean, what do you mean? Means r is constant. Huh? How r is constant? R square equal to x square plus y square. X and y will be different at different points. Then how it is? It is constant. This is what the circle is. X square plus y square equal to a square, that is the radius. It is constant. It will never change. If you decrease x, then y will increase. If you increase x, y will decrease in that fashion. R is constant. It never changes. But tan inverse theta, that is y by x, it changes. When x is a, then y is 0. Tan inverse 0 by a is 0. Means at this moment theta is 0. If this is x-axis, this at this moment theta is 0. What about this? X is 0 and y is a. Tan inverse y by 0, infinity. Tan inverse infinity is 90 degree. That is at this location, theta is pi by 2. But everywhere r is radius is r1. It makes a rectangle. Rectangular region in theta r plane get mapped into circular region in xy plane. Okay, in that fashion, in past video, to have the n cut, I chop the I chop the theta axis into n different part. I chop r axis into m different part. Okay, m for mountain, m different part. Okay, now I have a set of area. I have set of area. If there is a rectangle, then which height is a, that is the radius of the circle, and base is 0 to 2 pi. Now I have n into m number of sub-rectangles. Each rectangle has a width of 2 pi by n, and each rectangle has a height of a by m. Okay, if this is the case, then this rectangle will map in the xy plane, that is a circle, as a something like this. In xy plane, if this is xy plane, this is x-axis, this is y-axis. In that fashion, this is the radius and this is the angle in xy, not in r theta plane. This is radius and this is theta. If I take any ith, jth sub-rectangle in theta r plane, I have theta r plane where there is a rectangle, and I chop the rectangle into n different parts along the theta axis and m different part into r axis. I have m into n small rectangle. Let's take the ith section here and jth section here. That map to the one small rectangle which has a width of delta theta and height as delta r. That small rectangle will be mapped into the xy plane. If in xy plane I have a circle centered at the origin, in that fashion there is a if now here there is a rectangle, width is delta theta delta r. It is at theta distance from the origin and r distance from the origin. If this is theta r, I am talking about one small sub rectangle here. This rectangle, if I calculate the theta distance from the origin, it is theta, and distance for height from the origin, it is r. At theta and r point, I have a small sub rectangle, delta theta delta r. Along this direction, r is constant. Along this direction, theta is constant. Similarly, if I talk in the xy plane, same section in xy plane, with the relationship x equal to r cos theta, y equal to r sin theta. With that relationship, if I talk in that fashion, then okay, then if this is x-axis, this is y-axis, then typically this is r. R goes like this, and theta is the angle that goes like this. Okay, someone see, theta equal to tan inverse y by x. Means it is angle only, where r square equal to x square plus y square. Means r is a hypotenuse. If this is x, this is y, then r is hypotenuse. R square equal to x square plus y square. Theta is y by x tan inverse, that is the angle. Okay, means it goes like this. At any theta at any r, this is full A of the circle. A is the radius. At any r, any theta, if I move along r keeping theta constant, this is delta r. I move along theta keeping r constant, this is delta theta. From here to here, this is delta theta I. And from here to here, this is delta r j. What is the area of this subsection? This area of this subsection is a mapping from the area of sub-rectangle in theta r plane. Okay, if I have m into n sub-rectangles in theta r plane, then I have like this strip. I have m into n in this circular section also. If I add all, I get the area. Okay, now concept is what is the area? What is the area in theta r plane? That is delta theta I into delta rj. What is the area in the theta r plane? Summation I equal to 1 to n, summation j equal to 1 to m, delta 1 to m, area of the ijth section. Summation I equal to 1 to n, summation j equal to 1 to m, area of the ijth section, that is delta theta I delta rj. If I add full, he will get area into the theta r plane, that will be a into 2 pi. 2 pi a is the area, but here it will not be so because there is a mapping. Here the area will be summation I equal to 1 to n, summation j equal to 1 to m, area of this mapped section. Okay, where one side is radius, on radius this is delta r, and one side is arc. Arc moves delta theta. Arc moves delta theta, keeping radius constant, and radius moves delta r, keeping theta constant. This is the area of the ijth section. What is this area? This area is, if I have something like this, then it is better. We calculate it into vector. In past video we give different analogy. Here we will give different analogy. What is the analogy now? The analogy is that this is a vector. What do you mean by vector? If I have any 2 points, then I have a vector. I have a point x1 y1 and point x2 y2. There is a vector. That is x2 minus x1 I plus y2 minus y1 j. It is a vector. If I have a delta r, there is a vector. What is that vector? That is delta r unit vector, because theta is not changing. I believe it is all right. This vector is, if this is r1 and this is r2, this is delta r or jth section, delta r. So what is delta r? Delta r. What is this point? This point is r1, comma, any theta. What is this point? It is r2, comma, same theta. Theta is not changing. What is this one in vector? R1, comma, theta, sorry, r2, comma, theta minus r1, comma, theta. That is r2 minus r1 along the r unit vector. This is the unit vector if I take along the r unit vector. That is delta rj r unit vector. What is the vector in this direction? In theta direction, it is moving like this. What is these 2 points? This point, if I take this point is r comma theta. From base it is theta. What is this point? R is not changing. Then this point is r comma theta plus delta theta. This point is r comma theta. This point is r comma theta plus delta theta. Okay, if that is the case, then this is the mapped section from the rectangular section in the theta r plane. I am trying to find this area. This area is this vector cross product with this vector. If I take cross product of 2 vectors, I get the area underneath it. That technology we are using as a vector. Area of the one section in n into m subsection. Okay, what is this vector? This vector is this point minus this point. This point is r. This point is r comma theta plus delta theta. This point is r comma theta, delta theta I. If I subtract, it becomes delta theta I, theta unit vector. Okay, but if I take polar coordinate system in Cartesian coordinate, this is basically a Cartesian coordinate system where we have superimposed polar coordinate system. If I take any point, then it must be in distance, not in the angle. If this is radius, then theta cannot be another point. It has to be in distance. That distance is the arc distance from the 0, 0. That is the another distance. If this is r, then another point will be r into theta. That is the arc. That arc represents the theta. If this is r, then another point is r into theta plus delta theta. Now, if I talk about the vector between these two, then the vector will be r minus r unit vector plus r theta plus delta theta I, theta unit vector minus r theta unit vector. More or less, I'm sorry, this point is r comma r theta. This point is r comma r theta plus delta theta. Okay, if I take a vector, after subtraction, r will go away. It will be r theta plus delta theta minus r theta, r delta theta, theta unit vector. If I do cross product of these two, this vector is r into delta theta I, and this vector is delta r unit vector, delta rj of the jth section, delta rj, this delta r is not the delta r there. They are different. Okay, delta rj, delta r unit vector, and this vector is r into delta theta I, theta unit vector. If I do cross product of these two, I will get the area. But problem is, this vector is straight, I understand, but this vector is also straight, whereas we took it as a curved line. Because if I talk about r theta is another coordinate. One coordinate is, if this is the circle, this is the origin. One coordinate is r as per the polar coordinate. Another is r into theta, that is the arc. R into theta means from the base, x-axis is this. From the base, r into, if it makes theta angle, r into theta is the arc. Okay. Now, if I talk about this subsection, what subsection I am talking? This is delta theta I. Up. I'm talking about this subsection. This is delta theta I. This is theta, delta theta I. This is the one arc at R, and at another delta R there is another arc. This is the area I am talking about, mapping to the ith there section there. This area, this is the one vector. From, if I connect this point and this point, this will be a straight line. This is one vector. Cross product with another vector. It will give the area underneath. This area is mapping of the area there, that is delta theta I into delta rj. That area mapping here is delta rj, r unit vector, cross product with r, delta theta I, theta unit vector. That will come as r into delta rj, delta theta I. Can someone see the transformation? There the area is delta theta I into delta rj. Same area got mapped here as r into delta theta I, delta rj. But here it is not perfect, because this arc should be a straight line. We have taken 2 points on the end point on the arc and took the vector. If someone wants the straight line, then this delta theta I angle should be tends to 0. This angle should be extremely small, so that this arc, what we are thinking, and a straight line will be same. Okay, then it will. So now we have summation I equal to 1 to n tends to infinity. Summation j equal to 1 to m tends to infinity. Then area of one subsection. Area of one subsection is r delta theta I, delta rj. Okay, r we can consider as function over theta and r. So function over theta r, delta theta I, delta rj, 2 in 2 summation. It is a fit case to convert into integral calculus. How we convert into integral calculus? If I have a vertical multiplied by horizontal area of a subsection, and then we add for all the subsection, it will become integral calculus. At the beginning only we said. One is r means function over r and theta, that is the vertical. And then r is at j point, r is variable, r is at jth location. If this is the radius, I chop it into m part. At the jth part, what is the radius? If this is first part, second part, jth part, from jth part, what is the radius? That is the radius. So this is variable, function over r theta, delta theta I, delta rj, or delta theta r, We have delta gap. If I take in 3 dimensions, where this is theta and this is r, 3 dimensions. This is the theta r plane, and this vertical is whatever it is, function over theta and r, that is vertical, and horizontal is theta plane, theta axis and r axis. Okay, if that is the case, then if I cut theta and r the way we were doing, chop it theta into n part and r into m part, then I have a subsection delta theta delta r. Against this subsection, I have a height as function over theta and r. If I have divided my theta r plane into n part and m part, where n tends to infinity and m tends to infinity, then this is a pure case. Then I have a m into n subsection, where n tends to infinity, m tends to infinity. N into m subsection, where each subsection width and length is tends to 0. If that is the case, then I have function over theta and r and delta theta delta r in that fashion, where theta and r are independent each other. It is a pure case of adding all the all the sub volume. There we will, no, no, it looks like complex. Okay, take in two dimension one. Consider this line is theta r line. This is theta r line. This is function over theta r line. Now I have chopped into m into n part where m tends to infinity, n tends to infinity. This is the one section. This is function over theta r. If I multiply function over theta r with delta theta r, it is this area. If I add all the area, this is function over theta r d theta dr or d theta r. This is the pure case to fit into integral calculus. Now it will become integration. Integration. Now next what I am going to say, it is more important. Integration where limit is theta into r from the beginning, theta into r to the end, and function over theta d theta dr or d of theta and r. Since theta and r are orthogonal to each other, I can say d theta dr. Function over theta and r. What is the limit? Function over theta and r is r. D theta dr. I can integrate it. What is the limit? What do you mean by the limit? What do you mean by the limit? Limit means in what areas. If this is theta and r, the area of the limit will be area, not a straight line. What is the area? Area through which you are trying to calculate the limit. Okay, if I take theta r plane, then area is a rectangular area. Underneath this area, because theta and r will vary in a rectangular region, means integration in a rectangular region, integration within theta and r as a rectangular region, function over theta, d theta dr. Now we have two things. One is theta r plane, one is xy plane. Okay, theta r plane, xy plane. Okay, in that fashion, in xy plane we have a circle that I'm not worried about because this is not theta r. This is x and y. We superimpose theta and r like this. But actual theta r is somewhere else. Where there is a rectangle, I have to integrate it over rectangle if I talk in theta and r. So theta and r integration over a rectangle, r d theta dr, r square by 2. Rectangle means 0 to a square by 2. Theta 0 to 2 pi, a square by pi a square. Or in 3 dimension, if this is theta, this is r. If this is theta and this is r, this is theta r plane. Then this vertical is function over theta and r. If that is the case, then on theta and r, we have a rectangular region. I have to, in the rectangular region in theta and r, I have function over theta and r. See where from where we have proceeded. Now we have function over theta and r. What is your function over theta and r? That is r. R is constant. No, it is not constant. It is variable with the r whatsoever. Okay, if this is the height and base is theta comma r, that is a rectangular region, you have to integrate for this rectangular region. If that is the case, then theta will go 0 to 2 pi and r will go 0 to a. Okay, we will proceed here. What about if r is function over theta, r equal to cos theta, r equal to sin theta? What do you mean? In r theta plane, it is not rectangular. If it is a circular or something else, and then in xy plane, it forms a circle. In r theta plane, it is not rectangular, but it creates a circle in xy plane. Then how we will proceed? This is something dissociating in your problem, not only in vector, but two different coordinate system. And one coordinate system becomes a commander, controller, and where one coordinate system becomes a shower, view. In xy plane, you have view only, whereas it is controlled through the theta r plane. And then you do it through vector. Vector, summation, and integration. These are not available in any of the books. What is its importance? Importance is if you get to have any complex problem where there is no area volume. In integration, everything is calculated through area and volume only everything. Either you have a aerospace problem or you have physics problem, electronics problem, everything. Wherever you see formula, you try to match it into one of these, area and volume and this and that only. And then whatever the format is, just place into the format and you get there. We will see that use cases also. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 948